Welcome to Engineering Innovations, the official podcast of Purdue University's Elmore Family School of Electrical and Computer Engineering, where we dive into the groundbreaking ideas, bold research, and transformative technologies shaping our world. I'm your host, Kristin Malavenda, the Communications Director for the school, and today we're talking about something that touches all of our lives, digital media. From streaming your favorite shows to scrolling through photos on your phone to verifying whether a viral video is real or fake, the technology behind what we see and share is more complex and more important than ever. Our guest today is someone who's been at the forefront of this digital revolution for decades, Edward J. Delp. He's the Charles William Harrison Distinguished Professor of Electrical and Computer Engineering here at Purdue, and he's also a world-renowned expert in image and video processing, multimedia forensics, and digital watermarking. We'll talk about how his research helps us compress and stream videos more efficiently, detect tampered media, and even protect against deepfakes. It's high-impact, high-stakes work with global implications, and he's here to break it all down for us. Professor Delp, thanks so much for joining me today.
Thank you for having me.
So let's just start from the beginning. What first got you interested in electrical and computer engineering, and then how did that lead to your work in digital media that you're doing these days?
Well, I think this goes all the way back to my father. During World War II, my father was actually in the Army. He was actually in the Army Air Force, and he was an aviation electronics technician. So he worked on electronics in airplanes. And after he got back from the war, he started working, and he created a little side business. I guess we call him a side hustle nowadays.
Okay.
And he actually had a little business that actually repaired TVs and radios.
Oh.
And he did that based on some training he got with the GI Bill of Rights, and so he became very interested in electronics. So that eventually he had to stop that because working two jobs was just a little bit too complicated. So that he was very interested in electronics. He was very interested in something called amateur radio, ham radio.
Yep.
And so I got into that based on him. Okay, I like to say that the first TV set our family had, my father actually built from scratch from parts.
Wow.
Okay. And I still remember that. This was probably about 1952 maybe or something like that. So anyway, that got me interested. I got very interested in math and science in high school. And so when I went off to the university, I did my undergraduate degree in electrical engineering at the University of Cincinnati. I became very interested in this area called communication signal processing.
Okay.
Initially more on the communication side, but as I was going through the program there, I became much more interested in the signal processing side of that, and then I got interested in images. So what happened after University of Cincinnati, I stayed around and got a master's degree there, and I did some work for my master's thesis at UC in signal processing. And then I came here to do a PhD at Purdue.
Yep.
And the Purdue, even at that time, we're talking about this was maybe in 1976.
Okay.
Purdue was very well known in image processing. Purdue had been well known in image processing for probably more than 15 to 20 years. Okay. So I ended up working with a group of people here, in particular Bob Mitchell and Tom Wong, and I did a PhD dissertation in image compression. Then I went off to the University of Michigan for about 4 years, and then Purdue made me a deal I couldn't refuse, and I came back here.
And here you are today.
And here I am. I've been here now for the last 40 plus years.
That's great. Well, one of your major areas of research is image and video compression. So for anybody who might not be familiar with that, what does that actually involve, and why is it important?
Well, it involves the idea of trying to represent an image or video, and this also could apply to speech, with as few bits as possible. So you're talking about digital images, digital video, even digital audio. Although I haven't done hardly any work in digital audio. It's mainly been images and video. And the idea here is that if you can represent these information with as few number of bits, then you can either transmit them faster or transmit them with less bandwidth.
Okay.
That has a lot of implications. Right now, just about all the video that we consume now, there's almost no analog video.
Right.
All the video we consume, all the images we consume, all are digital. And all of those images are compressed. Unless you're working in a very specialized niched area, maybe some really scientific imaging or something like that, all those images are compressed. And the reason why, for example, you can watch Netflix on your TV at home is because that image is compressed using a particular type of compression technology, and it sends it to your home. You can watch it. So it's a very important area. Like I said, all the media we consume, all the digital images and digital and video we consume is all digital, and it's all compressed.
And I'm sure you see especially with the students today, everything they do is on their phone or on a laptop.
Yes.
So it is really important.
Yeah, I mean, this goes all the way back to my PhD dissertation, where we actually worked on a particular type of image compression technique, something called block truncation coding, which I did for my PhD dissertation. And every one of you have some version of block truncation coding in your laptop because it's used for graphics compression. Actually, and block truncation coding was one of the finalists for JPEG.
Oh.
But we didn't win. It was another technique that won. But this method has been used to transmit images from Mars back to the Earth.
Wow.
So one of the early Martian landers actually used a form of block truncation coding to transmit images back from Mars. So yeah, and so we worked on a bunch of other things related to both image and video, and this applies to all kinds of things. YouTube wouldn't exist. Mm-hmm. TikTok wouldn't exist without using compression.
Heaven forbid.
Yes. Well, there you go. Yes.
Great. Well, you don't just do image compression. You do a lot, actually, but you've done a lot of work in multimedia forensics, which is like digital detective work. So
Yes.
Can you explain what that is and why it matters in a world of deepfakes and manipulated media?
Sure. I got started in this, probably more than 20 years ago. And there we were more interested in protecting images and video, in particular video, that was copyrighted. This goes all the way back to when digital video and images first got started. There was a lot of issues about piracy. People worried about people being able to steal content and all the rest of the stuff. So we got into this area known as digital watermarking, where you would actually put an imperceivable signal inside an image or video so that you could then be able to determine its provenance. Okay, in other words, who owned it, maybe if you manipulated it, things like that. This then led to us also doing this work for printers. So we actually were able to determine, we could do the authentication problem where we could say, okay, here is a particular printed document. We can determine exactly which printer was used to print it.
Okay.
So we got into that area, and that is a form of forensics. We then, starting probably more than 12, 15 years ago, got into this area of looking at, okay, can you tell if an image or video or even audio has been manipulated or modified?
Right.
And this started some work then that we've been, like I said, working on for the last 12 to 15 years, developing techniques that we can determine if a video is authentic or not. This also then led into this area of synthetic media. You can generate video and images with, OpenAI or many of these other techniques. And so the question is, could you determine if a video was presented to you, whether or not it was synthetically generated?
Okay. So
we've done a lot of work in that area. We've also extended that to speech. So the question then becomes, there's some basic forensic questions you might want to ask. Let's say we'll just leave it to an image. So the first question is, has the image been altered?
Okay.
Where has the image been altered? Can you tell, maybe this person's face was changed or something like that. What technique was used to alter it? Okay. Who altered it, and why did they alter it?
Okay.
These are the so-called there's 5 or 6 forensic questions.
Yep.
We spent a lot of time looking at these problems. We were involved in several big media forensics projects involving the Defense Advanced Research Project Agency, DARPA.
Yep.
And so we again, our team looked at images, video, audio, in particular speech, and text. We also have done some work on looking at text forensics. So we've been doing that for a long time. Have done a lot of research in this area, produced a lot of students with PhDs working in that area. We're continuing. One of the things we're doing right now is sort of a fun project. Most of the work we've done in the past on speech forensics has used the English language.
Okay.
So I have a couple of students one from Spain and another one who speaks Spanish, who lives here, and we're redoing all of the work we've done in Spanish.
Oh, wow.
And probably Catalan, which is another language spoken in Spain.
Yep.
And I have another student coming to visit us for the summer, and we're going to redo all of our techniques also in Italian.
Oh, wow.
So we're looking at these other languages, and there hasn't been as much work published on that. The basic first question is, have the methods we developed for English will work with these other Romance-like languages?
Yep.
And the answer looks like maybe not.
Oh.
But it's still out yet. We don't know. It's still an open research. So we're working on that. We started that project quite recently, only maybe about 6 weeks ago.
Okay.
So that's one of the new things we're doing.
You know, when you talk about deepfake videos, you're getting videos from all different sources,
Right.
YouTube, all social media. Can you trust what you
Well,
see?
that's a good question. And I think we may come to some point in our society because, this idea, I make design techniques to be able to detect, say, example, deepfake videos. It's an arms race. The people making videos get better and better.
Right.
Our tools get better and better. But, there's going to come a point where maybe we won't be able to believe any type of content we see
Yeah.
unless we've seen it with our own eyes.
Right.
Okay, I mean the actual event
Yes.
happening. And that's bad because our society is based on trust mechanisms, all kinds of trust mechanisms. If those trust mechanisms get destroyed or warped in some way, then we're going to have real problems in our society. And so it really worries me.
Yeah.
I'll give you an example, a funny example. It's very controversial going on right now. So when we're recording this, this past weekend, the Walt Disney movie Snow White came out.
Right.
Okay. One of the controversies is that they chose for the dwarves, instead of using real people for them, they're all computer generated.
Oh.
Okay. And, the question is, so now we're sort of having, and this movie, of course, is for families and children. And so now we're basically having children go to a movie or to some sort of media event where they're going to start being used to seeing generated people.
Right.
It also, there's a controversy going on because a lot of actors who thought they could play those parts didn't get the job.
Yeah.
Okay. And I think that, I don't know, I haven't seen the cost-benefit analysis, but I wonder if it's cheaper, and we'll probably never know, but if it's cheaper to use computer-generated dwarves than to hire real actors.
Yeah.
And so we're going to see more and more of that. And then, what does this mean? Because in various ways, we consume media for all kinds of things, not just entertainment.
Right.
So one of my PhD students is working with a company that processes dental X-rays for insurance companies.
Okay.
And he is now they are now concerned that maybe dental X-rays, which goes through an insurance process to be reimbursed, what happens if you have an unscrupulous dentist submitting computer-generated X-rays?
Interesting.
Okay. What happens if you have an unscrupulous doctor producing computer-generated MRIs of somebody's lungs and submitting them to Medicare for reimbursement?
Gotcha.
So it's more than just what you're thinking of.
Just videos, yeah.
There's another student who is, in many cases, if you have a car accident, and let's say it's not serious, nobody's hurt or anything like that, it's just property damage, the insurance company will tell you, take a picture of your car, and then based on that, they may reimburse you. You might not have to take it to get it.
Right.
Okay. So I know of another one of my students is working for a company that helps insurance companies, auto insurance companies, process these images. And they're also worried about either computer-generated or computer-manipulated images to sort of make the car look like it's damaged more than it is.
Wow. That's also interesting.
So there's all kinds of things. There's also what I call, and I don't think this is an official term, the grandma scam, where you actually get a phone call, and it purports to be your grandchild.
Yes.
I'm in trouble. I need money. Send it here, and things like that. And the problem is that right now we can generate reasonable quality audio with 5 to 10 seconds of speech.
Wow.
And we can generate very good quality audio with 30 seconds of speech. That's why I tell people, you might want to start thinking about what you're posting to social media.
Right.
And so, if your grandchild is posting videos to social media where they're talking,
Yep.
we've also done experiments with this, we can grab the audio, the speech off of that video, and we can generate speech that basically says anything.
Yeah.
So, it's really weird. In this last presidential election, there was supposedly people were getting telephone calls from New Hampshire that were supposedly from Joe Biden.
Okay.
That said, "Don't vote." Okay.
Okay.
And actually, it wasn't a bad rendition of his voice,
Yeah.
and that was discovered that people did that. So, but I mean, you're going to run into all these issues about, okay, if somebody gives you an image or a video or some audio, was it really real?
Yeah.
I mean, we've seen this historically. One of the things that always has bothered me is if you look in fashion magazines, which young girls look a lot at.
Yeah.
Okay. Just about all those advertisements for fashion stuff have been altered.
Yes.
Historically, these are the so-called photoshopped images.
Yep.
Okay. And it's going to get worse. The problem, of course, we're hearing stories of, and I've talked to physicians about this, young girls look at these pictures. I want to look like that, but that person doesn't really exist.
Right.
Okay. And it causes all kinds of problems with eating disorders. These are usually young women that do this. I have granddaughters. It's
concerning.
It is. And I think this is going to get worse, and these tools are going to get so easy to use that everybody's going to be able to do this.
Well, that's interesting because I think about the tools that people are using to make these fake videos or altered images. Do you foresee a time where, we have antivirus for our computers? Would there be a tool that people can use to try and detect whether something's been altered?
Yeah, I think that's coming, and I can't say anything specific,
right.
But I know that the social media networks are worried about this. The problem, though, is that we have this issue of confirmational bias.
Right.
If I show you a video and it confirms what you believe, and then I tell you it's fake, you may not believe that it's fake.
Right.
Okay. A good example of this was, this is now going back for a while, maybe 8 years, maybe 7 years. There was a video of Nancy Pelosi, who at that time was Speaker of the House. And what people did is they took the video and they slowed it down, and they did something called dynamic time warping on her speech. And it looked like she was slurring. It sounded like she was slurring her speech, and because they slowed it down, it looked like she was, okay. That video is you can still find it out there on the internet, and it's labeled as being manipulated. Okay. But there are many people that still believe that. So we have this issue of, if some sort of content confirms what you believe or what you want to believe, even labeling it fake may not be enough.
Yeah, so there's not just the technical implications, there's the psychological implications. And once that video is out there, even if later it's identified as manipulated, people either don't believe it or won't see that information. Right,
and this goes also back to, I was reading an article this past weekend where they were saying that, it's one of the things that's happening, we're seeing this here in our undergraduate program in particular, but in high schools, students are getting used to using tools like ChatGPT to basically do their homework for them.
Right.
And also you can use those tools now to create images and videos and speech. And so the question is, if we got to do something about the education, because this might start getting baked into our young people, that this is just the way to go.
Right.
And, you generate content that basically meets your immediate needs. Now we can go, I can show my age and complain about people who shouldn't use these tools, but that's not, I don't believe that to be true. This goes back to the issue, you could make an argument about how people complained when calculators were introduced in high school. And so here, I know in my classes, I encourage the students to use the tools, but I want them to tell me they're doing it.
Gotcha.
Okay. And I think it's important that they come out of this university and understand the capabilities of these tools. But I think it worries me when they start, if you start saying it's my work product.
Right.
Okay. And so I don't know. I don't have the complete answers for this.
Right.
I really don't. But it really worries me about what's going to happen. I really am concerned. And, we're going to be bombarded with this sort of synthetic and generated content, and people are going to use it for all kinds of things.
Absolutely.
The typical thing that we used to worry about, and I was worried about this, but I was also worried about other things, was this idea of using it for some sort of pornographic type thing.
Right.
Rather either, synthetic child pornography or revenge porn. Those are all important. They're very serious.
Yeah.
Okay. But one of the things that always bothered me was financial crimes. And we're starting to see those really ramp up with the synthetic content.
Interesting.
So I think it's going to be very interesting. I think the whole, we had these, the situation in New Jersey, it was probably about 2 years ago, where these, a bunch of, there's a high school, senior class, a bunch of the boys got pictures of the girls, and they went and they did an application called Nudify.
Okay.
Which basically takes a picture of somebody and tries to put a synthetic nude on top of them. And then they posted those pictures of those young girls. And, that's terrible. The problem is, once you put something on the internet, it's there forever.
Right.
And so and I have granddaughters.
Yep.
And it's usually, many of these things are almost always either directed at women or children. Mm-hmm. Okay. And that still is a concern, but we're starting to see all this other stuff, we, in the future, we may go see a movie where, a large percentage of it are going to be synthetically generated.
Yeah.
But what about, people using these tools to commit crimes? I mentioned, medical fraud, insurance fraud, other types of things, trying to defraud you out of money because we're saying, I'm a relative and I'm calling you and I'm in jail, send me money.
Yep.
So those things all are very concerning. And, the question is, if we have tools for you to use, are you going to use them?
Yeah.
And are you going to believe
Right.
it?
Yeah. It's a good question, and I don't know that there's an answer to it.
Right.
So how do you talked about how you advance your technology, then we'll say the bad people advance their technology.
Right.
How do you guys try and stay up to date with what?
Oh, it's hard. I mean, we have to keep on tracking what's going on, what types of things that are available, particularly these newer techniques, and then be able to test our methods against them. The box of methods that you run against these techniques.
Okay.
So that's why it may be more difficult for right now, at least for an average person, to be able to do these. Many of these tools they're not ready for prime time in a sense. They're not ready. Click and download or click and run on your computer, but they're able to be used by businesses, social media, and of course, the U.S. government.
Okay.
And so we're going to start seeing more and more of those sort of coming down to people to be able to use. I think eventually the social media networks will offer these. There might even be methods like some photo editors, for example. I don't know for sure what Adobe's going to do, but I can see maybe in the future, you might import an image into Photoshop, and it might tell you that parts of it are manipulated or synthetically, Of course, the problem is Photoshop. The average person doesn't use Photoshop because it's sort of expensive in a sense. But I think we're going to see that. There's another thing that worries me, and that is, let's say, camera makers. And for most people, when I say camera, I mean their phone.
Right.
But I'm even talking about high-end cameras like the one right there.
Yeah.
Okay. These camera manufacturers are interested in putting these tools in the camera. So it's possible that the picture you see on the screen after you take it has already been processed and edited.
Oh.
And you really didn't see the actual image.
Right.
Okay. And then, the question is, what is the real image? Okay, is the real image by definition the thing that came out of your phone? To me, that's not.
Right.
But, I do this for a living.
Right, yeah.
So, but that's coming. There's no doubt about that. That's coming. And we know right now that both on the Android phones and iPhones, they have editing tools right on the phone for editing both video and images. And, the question is then, what is the original image?
Yeah.
Okay.
Yeah, and people
I mean,
probably disagree on what that is.
Right. And so that whole thing starts getting complicated, and then it really has to lead into some policy arguments and also educational arguments.
Mm-hmm.
What are we teaching people in grade 1 about this?
Yeah.
Or grade 2 about this?
Yeah.
And so I don't know, and it worries me. And again, I think what's going to happen 20 years from now?
Right.
20 years from now, is it possible nothing is going to be? Everything's going to be manipulated to a certain extent.
Right.
And so I don't know.
Well, and the thing is that if you're starting from such a young age, which any 2-year-old knows how to use an iPhone now, right?
Right.
That are they developing critical thinking skills, or are they just
That's
accepting
correct.
what
That's
they
correct.
see? So
Yeah, and I think that it really comes down to what do we want to train, since I'm in a university
Mm-hmm.
here. So I'm interested in one of my jobs. I always brag. My job is to make Purdue engineers.
Yep.
That's my job.
Yeah.
Okay. And when we make these Purdue engineers, and I'm very proud of the Purdue engineers we make here at Purdue University, what are the skills that they really need to be able to have? And, one of the problems with these techniques, and using artificial intelligence methods, machine learning methods in general, what do the students really need to know? And that's a debate that's going on inside of the university, very healthy debate.
yeah.
But I think at the same time there are some basic things people need to be able to do. And we're having those discussions here at Purdue. And I think it's good.
So over your decades here at Purdue, you've had any number of students come through your program, through PhD, through undergrad.
Yes.
What do you view as your responsibility in terms of mentoring? What are you wanting to do with the students to make them more successful or
Yeah.
just more aware when they leave?
Well, I mean, I think that they need to start. What I tell my students is that they need to break out of this sort of being in a student mode and start thinking like a professional,
Gotcha.
like an engineer. And so I teach a couple of courses that were oriented towards senior design, and I'm pretty hard on them. Okay, because when they go out and work for a company, they're going to find out that it's not the same as being
Right,
here.
right.
And so I want them to be able to do critical thinking, and I want to make sure they understand the basics, because things are going to change. 25 years from now, we're going to be beyond machine learning into something newer.
Right.
And they need to be able to have the skills to make that transition. And they can't treat things just as a black box and we just use it.
Right.
I always give an analogy to my students. You can fall into this sort of mode with machine learning that you just run it, you don't really understand how it works.
Yeah.
Okay. And I tell my students, well, would you like your grandmother to be on an airplane where the engineers designed the control algorithms using a black box technique? They really didn't understand how
Yeah,
it worked.
right.
So I think that's, these basic critical thinking skills. And that is hard to learn, and it's sometimes difficult. And I think it's important that the students be able to understand sometimes they need to be able to reach beyond their grasp.
Yeah.
And particularly be able to learn new techniques. And if they're using new tools, they need to have some idea what are the capabilities of the tools and how do the tools work.
Yeah, go beyond just getting
That's
an
correct.
assignment done and learning
That's correct.
the background.
That's correct. And I would like to see some of this get down into high schools too.
Okay.
Because I do have some freshman students in this. I teach in this VIP program we have here. You should probably do a podcast on
Okay.
that. This is the Vertically Integrated Projects course. And students there can take it anytime in the program, and we've had students that have taken it every semester they're here, for all 8 semesters. But I see freshmen come in, and I would like to see some of these critical thinking ideas get down into high schools.
Yeah.
But that's what I think. Learning the basic methods and everything like that is great. But this idea of being able to adapt, I tell my PhD students, less than probably 5 years after you graduate, you're going to be working on something else.
Right.
And you need to be able to have those skills. I think that's what we need to do, and that's what we continue to strive to do. But we got to make sure we expose our students to these tools so they understand what are the boundaries of the capabilities of the tools, and even to a certain extent, what's the ethical use of the tools. Okay, and I think it's important. When I tell the students, when you graduate and go out and get a job, make sure you understand what's the boundaries of your company. Don't just assume you can start using these tools because maybe they don't want you to do that.
Right. Yeah.
Particularly now. Now that's I'm sure that's going to change in the future.
So when you're looking for, in particular, PhD students, like work in your research group,
yeah.
What qualities do you look for in a student that make you think, okay, this person's going to be a successful engineer?
Well, what I look for in particular, now we're talking about a PhD student.
Yep.
Okay. I'm interested in what their basic skills are, in particular whether their mathematics skills and what kind of programming skills they have.
Okay.
And right now, I'm not, I'm on the programming side. I want them to be able to write real code. They can use some of these ChatGPT and things like that to help them write code. But I'm interested in do they really understand what's going on and what are their mathematics background. And then, to a lesser extent, what was the courses they took as an undergraduate student. So my PhD students take a lot of math classes because I think that goes back to looking at the fundamentals. And then we sort of go forward from there. I also want them, one of the things they have to do, and this may be controversial, is when they're graduate students, they have to stop thinking like an undergraduate student.
That makes sense to me.
Yeah, they have to start thinking, they can't treat their research as a homework problem.
Right.
And remember, I always tell them two things. The word research has the word search in it. And if you learn something new, your head will not explode. Okay?
That's good advice.
Yes. And so that's what I'm looking for. If they, and so they don't need to have even necessarily all A's or anything like that. I mean, I do look at the grade point average, but I'm more interested in, maybe what have they done? Have they maybe worked as an undergraduate, did some research project, do some intern work? But more importantly, what are their basic skills?
Gotcha.
And then, I'm pretty selective. So, yeah.
It's important work. So.
Yeah, and my students have done well. I mean, they've gone off and, they work at all the great places that you would want engineers to work.
So we keep going back to you've been at Purdue for so long, and you're still obviously very passionate about what you do.
Yeah.
How have you, a lot of people who work at the same place doing some of the same stuff for those years get kind of bored with it. How have you kept your motivation and your passion going?
Oh, one reason is that I hang around with a lot of really smart young people.
Yeah.
And I think that helps me, keeps me going. One of the things I like with my graduate students is I want them to argue with me.
Okay.
Technical arguments.
Yep.
And, I always say when I start losing the arguments more and more, it's time for them to graduate. Okay. So, yeah, I mean, this whole intellectual discourse is really important to me. Working with the students, both the undergraduate students and the graduate students, I always like to see undergraduate students go and be very successful.
Yeah.
Either go on to graduate school, not necessarily even here. It's great if they stay, but go on and have careers in all kinds of areas.
Yeah.
Okay. So that always makes me feel good. But I think the fact that I'm hanging around with a lot of young people, both in the undergraduate and graduate program, I think it keeps me intellectually stimulated and keeps me on my toes.
Yeah.
And so I think that's it's a very unique job. I'm very blessed to have it, and I think it's been fun. But it is a job, and there are parts of it I don't like.
Of course, absolutely,
So,
absolutely.
Yeah.
Well, when you're not teaching or in the lab or whatever, what do you like to do to decompress or just have fun?
Well, my hobbies, if you want to call them that, or they're sort of derivatives of my work.
Okay.
So one of the things that I do, I do work in, I do some photography. I'm getting interested again to back into amateur astronomy, in particular astrophotography, so the digital images keep on going through it. I'm still active, not as much as I want to be in amateur radio.
Yep.
Also, I'm interested, I'm in the process of taking the FAA course to become a certified drone pilot.
Oh, wow.
So hopefully I'll take the exam in a little bit and get that. I'm not interested in doing anything commercially. But again, I'm interested in looking at drones, and again with cameras on them, so this whole issue of images flows through there. And so those are the types of things when I have time I play around with. I have in the basement of my house, I have a very nice electronics shop.
Okay.
I'm an electrical engineer, so I like building things.
Yep.
So I do that. The other thing I do is my house here in West Lafayette is very smart.
Okay.
So it has a lot of sensors in it. It communicates with me together. I have some outwardly facing websites to be able to communicate with the house and things like that. So that's sort of a little hobby on the side that I continue.
That's really cool.
Yeah.
Well, I've really enjoyed this conversation. It's fascinating. I feel like we could probably talk about it all day. But thank you so much for joining me today and shedding some light on this topic.
Well, thank you for having me.
So that's it for this episode of Engineering Innovations. Again, thank you to Professor Edward J. Delp for joining us and sharing insights into the fascinating and vital world of digital media, security, and forensics. If you enjoyed this conversation as much as I did, be sure to subscribe to Engineering Innovations wherever you get your podcasts. Don't forget to like, comment, and share. And if you're curious about more of the cutting-edge research happening at Purdue's Elmore Family School of Electrical and Computer Engineering, you can check out our website at purdue.edu/ECE or follow us on social media, and all those links will be in the show notes. We'll be back next month with another new episode.